A man A is traveling in a train T. The train is moving with a uniform velocity. What will be the velocity of the man? Just by mere observation, we can say that the velocity of the man will be the same as that of the train. But what makes us so sure? Because the man is in contact with the train and the man does not move relative to the train. Let's see what we mean by that. By this we mean that if we take the left wall of the train compartment, the distance between the wall and the man does not change as the train moves forward. Let's see that again. The displacement of the man A with respect to the train does not change, so this displacement is a constant. The velocity of the man with respect to the train, VA with respect to t, is by definition the velocity of the man A minus the velocity of the train t. Since the displacement xa with respect to t is constant, the velocity of the man with respect to the train, VA with respect to t, has to be 0 since the velocity is the derivative of the displacement. So we obtain the velocity of the man as equal to the velocity of the train. The bird or observer on the ground sees the train and the man moving away from itself with the same velocity. Now this was a case where the man was stationary with respect to the train. Let's now take cases where the man begins to move inside the train compartment. Now the man begins to move in the train towards the right, and we'll put some numbers here. Consider that the velocity of the train is 6 meters per second. The man walks with a velocity of 1 meter per second with respect to the left wall of the train compartment. So this would mean that x a with respect to t, or the displacement between a and t, is increasing at the rate of 1 meter per second. So what is the velocity of the man with respect to the ground? By definition of the relative velocity of A with respect to t, it would mean the velocity of the man A with respect to the ground minus the velocity of the train t with respect to the ground. Since the man A is moving away from the left wall of the train compartment with a speed of 1 meter per second, VA with respect to t would be 1. The velocity of the train is given to us as 6 meters per second. From here, we obtain the velocity of the man A with respect to the ground as 7 meters per second. So what do all these figures mean? To the bird or observer on the ground, the velocity of the train would be 6 meters per second, meaning that this wall moves away from the observer at the rate of 6 meters per second. But the velocity of the man would be 7 meters per second, so the man is moving at 7 meters per second with respect to the observer. The observer feels that the man is moving away from itself at a faster rate than the train, and this is because the man has the train velocity and besides walks within the compartment further from the observer, thereby adding to the speed as seen by the observer. To a person sitting in the train, the man is walking at 1 meter per second, but to an observer on the ground, the man is walking at 7 meters per second. Now let's take a case where the man walks towards the left wall of the compartment with the same speed of 1 meter per second. This time, the man walks leftward inside a moving train. So while the train moves towards the right with a speed of 6 meters per second, the man walks towards the left with a speed of 1 meter per second with respect to the train. And we apply the mathematical definition of relative velocity of the man with respect to the train. Since the man A is moving towards the left wall of the train compartment with a speed of 1 meter per second with respect to the train, VA with respect to t would be -1, and this is because the man will be approaching the compartment wall in the negative direction of the x-axis. And you can see that the displacement xa with respect to t reduces. The velocity of the train is given to us as 6 meters per second. From here, we obtain the velocity of the man A with respect to the ground as 5 meters per second. Let's now try to extract the significance of these numbers from the stationary observer's point of view. To the bird or observer on the ground, the velocity of the train would be 6 meters per second to the right, so the left wall of the train compartment moves away from the observer at the rate of 6 meters per second. But the velocity of the man with respect to the observer would be 5 meters per second to the right. Although the man walks to the left, the net displacement between the man and the observer keeps increasing at every instant at the rate of 5 meters per second. The observer feels that the man is moving away from itself at a slower rate than the train, and this is because the man has the train velocity and besides walks within the compartment towards the observer. To a person sitting inside the train, the man A is walking at 1 meter per second backwards, or mathematically -1 meter per second, but to an observer on the ground, the man is walking at 5 meters per second. When a person walks inside the compartment of a train, the speed of the person as seen by a stationary observer on the ground will be different than the speed of the train. It could be greater or less than the speed of the train depending on the direction of movement of the person within the train.